So hello and a very good evening to everyone. Today we are going to start with our first subject, air navigation, and the first part of it, which is general navigation. There are two other parts too. The second is radio aids, and in the end, the instruments, which we are going to do later. But we are going to begin with the introductory video for general navigation, and these are all the topics. Before we proceed to this, I would just like to mention my focus on making all the videos of this series will be on two things. First, to make imagination as easy as possible for all of the viewers, and second, to collect as many facts I can collect from two major books, R.K. Bali Air Navigation and Oxford Air Navigation, that I personally used for studying during my air navigation exams, which I have cleared. So let's quickly begin with the introduction of all the topics, what we are going to study under this. So first is the solar system and twilight period. These are interconnected topics, and that's why we are going to cover both of these in the first video. So what's new for the solar system? We have all studied about it in our earlier classes, in class 7th or maybe class 6th. But what we are going to study under this is going to be something new. What's that? Something like the earth is tilted 23.5 degrees about its axis, and this is what leads to seasons that we see. Or something like the fact that in a year there are not only 365 days but 4 hours, 48 minutes and 45 seconds to be precise. Like this, we'll see more facts in the video that will cover the first topic, and we will move to the second topic, Earth, compass and directions. Again, what's new about Earth? We have all studied it earlier, but we are going to see some new topics. Great circle, rhumb line, what are these? So these are actual things that pilot use in real life. How? Great circle, it is the shortest distance between two paths. If you have ever noticed in maps in which aircrafts are flying, if you see above the Atlantic Ocean, you will see a curved path on which a lot of aircrafts are flying, and like it's a highway. Why is it so? It is a great circle path. From both the directions, left to right, right to left, you will see aircrafts flying on it because it's the shortest path. It saves fuel. That's why you are able to see it like a highway. In the compass and direction part, we are going to see what are the different kinds of directions we are going to have, like not north, east, west, south, but something like true north, magnetic north, compass north. What is the difference between the three? What is deviation? What is variation? How to calculate all of this? All of this will be seen in very detail in compass and directions. Then moving to the introduction of a third topic, convergency. It is one of the topics in which I've seen a lot of my friends struggle. And why is that? Because it is difficult to imagine all the meridians at equator and why is it converging at the poles. We are going to use the actual globe and a lot of imagination scenarios to study convergency and to make it easier for all of you. After that, wind triangle and 1:60 rule. Very important and very practical. No need to rote learn these all things. This comes into actual use and it's very easy to apply. Like wind triangle. Why is this needed? Aircraft is flying, wind is coming from the side, and the track of the aircraft is changing. The difference in the heading and track, drift. We are going to study all of this in more detail, and we are going to solve question for this that actually comes in exams. Also for 1:60 rule, very important rule, we are going to derive it from zero and we are going to see how to use it, whether it be climbing, descending, how it comes into use. Then next, scale and units. Very easy topic, very easy to apply and understand, but one thing is very necessary, that you do it step by step and in a certain process so that you don't do silly mistakes in this. Let me show you a quick example where the scales and units we have always seen. You've seen Google Maps, right? You'll see in the bottom right corner there is a small scale like things. It tells 2 kilometers, 2 miles, etc. etc. Why? So that we can understand that the distance we can see on the map, how much distance is it in actual when we actually travel from one place to another. The scale and units will help us in that a lot. Then projection. Again, not a difficult topic, but too much to imagine in this. how we are going to create different types of maps using a globe. What kinds of maps are there? Mathematically created, actual created with cubicles and the light source. We're going to study all of it in detail under this projections. Then comes a very interesting one, time. Very simple, but it's more than that. Why time? What we need to study about time? UTC, GMT, local mean time, a lot of it we are going to study and understand how we are going to use it in actual day-to-day life. Like, let me give you a quick example. It's currently 9 p.m., but if you want to calculate about New York's time, what it would be. So if we know the difference that New York is 9 hours and 30 minutes behind us, so easy to calculate. Let's subtract 9 hours and 30 minutes. It would be 11:30 a.m. in New York currently. It is just a small example. We are going to do a lot of it and how to calculate the time at certain place. And we're going to study it in chapter 7, time. Then CPPNR, very practical topic. How it comes into use. Let me give you the full form first. It's critical point and point of no return. What is this? Let me give you just a brief. So critical point is the point from which the time to the destination and the time to the departure aerodrome is equal. Mention one thing, not the distance, but the time to reach that is equal. That is CP. If you talk about PNR, point of no return, my teacher taught me that how fighter pilots actually use this. So going on a mission, there is a PNR given to them. Why? If we cross that PNR, if we cross that point of no return, we are in a path from which our fuel is not enough to take us back to our departure aerodrome. The fuel is not enough for that. That is PNR, and that's how it comes into actual use of pilots too. Payload. It is about the weights. Aircraft's weight, basic empty weight, the weight of passengers, luggage, how to manage all of it, and what are the regulatory limitations such as MTOW, maximum takeoff weight, how to calculate it, how to solve questions of it, we'll see in the payload chapter. Then weight and balance, again a very important, very fun chapter to do. As we have all seen the example of seesaw in our earlier classes, the teacher used to teach us make a seesaw, change the pivot point, and we could keep two different weights at it ends. How it comes into use in flight. The wings of the flight acts as a pivot on which the entire fuselage is settled upon. So if we change the weight, the center of gravity, it is very much prone to go either downwards or nose up, which is very dangerous for the flight. Let me give you a quick example. National air flight in Afghanistan, a Boeing 747. First of all, I was thinking there is Boeing 747 in Afghanistan, but there was one in 2013, which was carrying armored vehicles for army and which crashed. Why so? The weight and balance was mismanaged because the cargo it was carrying was not correctly fastened. The cargo got loose, weight and balance was completely destroyed, and the plane went nose up so much that it crashed. Let me just write it down quickly. Just so you can remember it for further references, the air crash investigation come into a lot of use in maybe saying it in group discussions or interviews. It is very important. Then fuel planning, our 11th chapter. Again, how we actually calculate fuel in our real flights. We are going to study under this. Different types of fuel. Trip fuel is not the only fuel we have. Reserve fuel, fuel to alternate, holding fuel. All of these are taught under fuel planning, and what are the Indian regulations that makes the carrying a certain amount of fuel necessary. We are going to see it under fuel planning. Then after that, INS and IRS, full form Inertial Navigation System, Inertial Reference System. Both do majorly the same work. The difference is this: INS uses a gyro-stabilized platform and accelerometers in it, whereas IRS uses ring laser gyro. Very important term that you will need to remember and which will be taught in very much detail under this. So what it basically does, it takes the initial point of the flight, and based on the acceleration of the flight, it integrates it and finds the actual distance traveled by the flight. So if we input the initial coordinates of the flight and our INS has got those values, it will give us the live data of where the flight's coordinates currently are. This is the use of it, and we are gonna, again, as I said, study it in more detail under chapter 12 in the 12th video. Then flight plan. A lot of things to discuss under this, like what are the things that pilots need to mention in this plan, whether it be the off block time, the time at which the brakes are removed and flight is ready to move, about the passengers it's carrying, about the endurance it has, means how much time it can fly. A lot of information is entered into the flight plan, and a lot of important data are mentioned into it, such as the route, flight level, a lot of things. We are going to study it all under flight plan, all of it in very detail. Then flight performance. What is this performance? The way humans' performance depend upon the environment in which the human is living. Similarly, flight performance will do too. If we change the air density, the takeoff distance will be longer. The landing distance will be longer. Why? Because the resistance by air, the lift provided by air will also decrease because of the decrease in density of air. We are going to study it in more detail, and we are going to study how all those factors can possibly affect our flights in this chapter. Also, the different distances, maybe you would have heard takeoff distance, landing distance available, then the different speeds, V1 speed, VR speed, VLOF speed, what are these and what is the use of this? We'll study under performance. Then 15th, ISA and altimeter settings. Again, bit interrelated to each other, that's why I've combined both of these. So what's ISA? International Standard Atmosphere. What is this? Why is this important? So it has a certain set values which we also need to remember, and on which is taken as the base for a lot of calculation, like engine calculation. If an engine is producing 44,000 pounds of thrust, so where is it producing? In India, in USA, where? Because if the air density is different, the thrust will be different too, because the engine is producing the thrust using the air only. So there comes ISA into use. If we say that this engine is producing 44,000 pounds thrust, it is under ISA. ISA condition, let me just quickly go through that. 15 degrees Celsius is the temperature at mean sea level. The pressure at mean sea level is 1013.25 hectopascal. In ISA, it is assumed there is no humidity at the mean sea level, where in actual there will be some humidity, but in ISA, we assume that there is not. Altimeter settings, very important topic, and a lot of questions come in, not only this navigation but also meteorology regulations. What's this altimeter setting? So when we say our flight is at 33,000 feet, it is from where? It is from the ground below us, or is it from the sea below us? We are going to study all of the different settings that we set in our altimeter, QNH, QNE, QNF, QFE, all of it, and how this affects our altitude. By the way, for the answering your question, if we are above a certain altitude, we will need to set the QNE, the standard altimeter setting of 1013.25, and if the flight is at 33,000 feet, it is with respect to QNE. Then this is the end of all the 15 chapters and the introduction, and I'm going to post further videos for describing all these chapters one by one into very detail. So thank you. Jai Hind.